What's poppin', dogs? Mr. Allen here with some graphing of exponential functions and their inverses, the logarithmic function here. So we're going to start with our exponential function, 4 to the x plus 3 minus 8, so a couple transformations. We'll get our domain, range, asymptote, end behavior, asymptotic behavior, and do the same for our logarithm. So I have a t-chart right there. I like to work with those. We're going to have ourselves x and f of x up there for our x and y coordinate. And then we're going to pick some inputs here. So I like to think about smart inputs. And what I mean by that is what's easy to raise 4 to? Like what power would be easy to work with? Well, 4 to the 0 would just be 1, right? So what x value would give me 0 in the exponent? That'd be negative 3. I'm actually leave a little space for this one for an extra value above, okay? So if I plugged in negative 3, I'd get 4 to the 0 power, which is 1. And 1 minus 8 is negative 7. So there we go. Now, what would give me 1 in my exponent? Because then I'd have 4 to the first, right? Well, if I put negative 2 in for x, negative 2 here, I'm going to have 4 to the negative 2 plus 3, so 4 to the first. 4 to the first is just 4, minus 4 is minus 8 is negative 4. And let's do one more here. How about getting 4 squared, right? How could I get 2 in my exponent? Well, I'd have negative 1 in for x. Negative 1 plus 3 is 2. So 4 squared is 16. And then we'd have 16 minus 8 is 8. Okay, so that was negative 1, I said. Cool. So we got 3 wonderful points that are going to fit. We could even go with like a, let's see here, a negative exponent. But then if I did that, check this out. If I did a negative exponent like negative 1, I'd have negative 4 up here. That'd give me 1/4. And then we'd have 1/4 minus 8. That's what, negative 7 3/4, negative 7.75. I don't know if I really feel like dealing with that, right? So maybe we don't worry about a negative exponent there. You can do that if you'd like. If your teacher requires it, that's cool. That's how you do it. I'm not going to go that route, okay? I'm going to work with the 3 nice points that I picked. 0 was in the exponent, 1 was in the exponent, and then 2 was in my exponent, okay? 0, 1, and 2. Beautiful. All right. So there we go. We got ourselves some nice points. Let's plot them. Negative 3, negative 7, 1, 2, 3, 4, 5, 6, 7. And then we have negative 2, 1, 2. And then negative 4, 1, 2, 3, 4. And we have negative 1, comma 8. So 1, 2, 3, 4, 5, 6, 7, 8. Woo! It's a base of 4, so it's going to increase really, really fast, right? Way faster than a base 2 or base 3. It's increasing exponentially, if you will. Get it? That was good. All right. Anywho, how about our asymptote? Well, our asymptote of our parent function for 2 to the x, 3 to the x, 4 to the x, whatever, in this case 4 to the x, that's going to be y equals 0. But that minus 8 on the outside has shifted our graph down, shifting it down by 8. So I'm going to go down to negative 8 here, and I'll put myself an asymptote right there. So we're going to have a dashed line in pink to match our graph. Yay, boom. Okay. And then I'll put my arrows on it. Pew, 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 pew. I want to make sure that we can see everything on the screen. I haven't recorded on this. Here we go. It's working. It's working. Okay. All right. Now we can connect our dots, right? And we're going to get really, really close, okay? And I'll even zoom in here. We're going to get really close to our asymptote, but never really touch it. Shoot through these dudes, okay? And I may have overshot things a little bit because I got to get really steep really fast. But we can still do it. We can still do it. Oh, nope, I can't. Okay, I got to do that one again. Oh, my goodness. Come on, Mr. Allen. Okay, let's try that again. Really close, get really steep, really shoot up. Okay. All right, let's see if I can get that one this time. Boom. All right. Feel better about it now. Cool. So there's my exponential growth function there. F of x equals 4 to the x plus 3 minus 8. And what I'm definitely going to do here is label this as f of x, okay? I always require kids to label them f of x, especially if we're dealing with an inverse, in this case, f inverse of x, right? And I'll even label my, my asymptote here. That's going to be y equals negative 8. Just pop it on down there. Label it all. We all know what's happening now, especially the f of x, though. That's definitely a requirement. All right, so now let's talk domain, range, end behavior, all that good stuff, and then we'll get to our logarithmic function, right? And I'll show you guys how to get that as well. So for domain, x is going to be all real numbers. So x equals all reals, because I can plug in anything for my x's, left, right, negative infinity to positive infinity. That's another way of writing this. You could, if your teacher wants interval notation, you could write it as negative infinity to positive infinity. You do not need both what's in the pink and the white there. The other one's just interval notation, okay? Range, I'm always above the -8. I'm never going to touch that -8. So we have y is greater than -8. Okay, cool. And then we could write that in interval notation just in case your teacher wants that. We have from -8 to positive, negative 8. I'm used to my infinities. -8 to positive infinity. That's messing me up, bro. Again, parenthesis with that one, okay? Parenthesis with the -8 because we're not including -8. It's an asymptote. You can never get there, okay? And then what's our asymptote? We've been saying it a whole lot, right? It is y equals -8. Beautiful. Beautiful. Okay. How about our end behavior? Well, as x goes to negative infinity, as x approaches negative infinity, what's f of x approaching? Well, that's going close to the horizontal asymptote, so -8. And then as x approaches positive infinity, what's f of x approaching there? Well, as I go towards the right sides of the graph, that thing's just shooting straight up, right? So it's going to positive infinity. Arrow. There we go. Going to positive infinity. As we go to the right, it's going up. As I go to the left, it's getting close to that horizontal asymptote. And then we have ourselves asymptote behavior. And this might not be the best question to ask for exponentials because we really cover this part right up here, right? Because we're talking about, when we're talking about end behavior, we're also talking about it's approaching that asymptote, right? So because it's a horizontal asymptote, we're approaching that one, or as we're approaching negative infinity rather, we're approaching the value of that horizontal asymptote, but never quite getting there. So we could write that down there again. Maybe not the best question to ask, but if it is asked, that's what we're really talking about. As x approaches negative infinity, that's when we're actually approaching our asymptote, which is, oh my goodness, I keep on wanting to write the 8s and infinities. We're approaching that -8, that value of that horizontal asymptote, all right? So wonderful. The log is done. Or sorry, the exponential is done. Time for the logs, okay? So to graph this thing, we're going to do our inverse, okay? So we're going to swap our x's and y's. I think that's easiest to do when you have a t-chart, right? When you have a t-chart, I can switch my x's and y's. So I can just write down all my, let's see here, x, and then we have f inverse of x for my t-chart. I can write down all of my x's, which were my y's previously, right? So -7, -4, and 8. And then I can write down all my x's, which are now my y's. So we got -3, -2, and -1. I like to do them in a row like that, so I don't like to switch them and do them. I like to go down the row, or down the column, rather, okay? So I like to do it that way. To each their own, whatever you want to do. That's how I keep things like straight, okay? Now we can plot those, right? I got -7, -3, so 1, 2, 3, 4, 5, 6, 7, -3. And then I've got -4, 1, 2, 3, 4, -2, boom. And then we have 8, -1. So 1, 2, 3, 4, 5, 6, 7, 8, -1. Cool. And where do you think our vertical asymptote is going to be? And why did I already pick vertical? Well, if the previous one was horizontal, my x's and y's switch. Now it's going to be an x equals for an asymptote here, and it will be x equals -8. The x's and y's switch, all that stuff switches, including domain, range, all those wonderful things that we're going to talk about here in just a sec. So there we go, boom, boom, pop some arrows on it. I'll label it as x equals -8. We can even throw that in there right now, x equals -8. Nice. And I can connect my dots based on kind of what I know from the previous one. I'm going to not zoom in this time because that really seemed to throw me off. Oh, I'm already thrown off. Get really close to it, curve, and shoot over. Got it. Yes. Boom. There is my inverse. And it does appear, I'll go to a 45-ish right here. There we go. Got it. Nice. It does appear to reflect over that y equals x line, doesn't it? Oh, yeah. Thanks, guys. Yeah, it does. All right, so this is y equals x. Don't forget to label this guy as f inverse of x. Don't want to lose half points, you know? Don't want to lose half points, man. Hard to see that one. It blends in with the lines there, but there we go. So got to label your graphs, got our asymptotes, everything checks out. I even threw in the y equals x line there, which is really nice because you see that it reflects over it. Lovely. Let's go with domain and range now. You could shortcut this thing, kind of just swap stuff around, but we'll talk about it for this one, okay? Domain, I'm always to the right of that -8, so x is greater than -8. Or we can go from -8 to positive infinity. Nailed the infinities and the 8s on that one. Very excited. And then I got range. Well, range, it keeps going down and it keeps going up as it goes to the right. So here we're at all real numbers. Y equals all reals, which you can also write as the -infinity to positive infinity if your teacher prefers interval notation. Asymptote we already took care of. Now it's end behavior. And I'm going to give myself a little more. We're going to zoom in on this here. So end behavior, actually, we probably want to see the graph. End behavior here, as I go to the left, as I go to negative, right, negative infinity, I'm getting to that vertical asymptote, aren't I? So as x approaches, and we're actually going to say -8, because it never goes to negative infinity. So as x approaches -8, and which way is it approaching it from, the positive side or the negative side? I realize that we're in the negatives there, but I'm coming from the right-hand side. The larger numbers or the more positive numbers are over on that right-hand side. So we're going to say from the right with a little plus sign up here. That might be new to you. All right, so as x approaches -8, from the right, we're going down, right? F inverse of x is going to negative infinity. Okay. Now we got the full screen. All right. And then that actually is also going to be our asymptote behavior, right? I'll just write that down here. As x approaches -8, our asymptote, from the right, f inverse of x approaches negative infinity. So we could write that for that one as well. It's kind of a redundant question, but it's a question that can be asked, okay? And then lastly, as x approaches positive infinity, as x goes to positive infinity, what's f of x doing here? F of x, f inverse. Oh my goodness. You could lose half points for that. F inverse of x is approaching. Well, it's going, as it goes to the right, it keeps going up. Doesn't look like it's going up by that much, but it does keep going up. So positive infinity. Boom. Nice. That's everything except for our inverse. So I'm going to show you guys how to get the inverse so we can pop that answer right here for f inverse of x. All right? So I'm going to take that f of x equals, I'll do this in light blue here, f of x equals 4 to the x plus 3 minus 8. And we're going to work with that one, okay, here on a separate screen or lower here. First thing I'm going to do is I'm going to switch my x's and y's. Remember, f of x is just our y, right? So I'll have x equals now 4 to the y plus 3 minus 8. Now what I need to do is I need to resolve for y. First thing is an algebra 1 move. I'm going to add 8 to both sides. So x plus 8 equals 4 to the y plus 3. But now we're bringing in the algebra 2 stuff where I need to rewrite this in log form. So I like to do what's called a loop and swoop, okay? We loop it, we swoop it. I start my loop with the base, the 4. I loop around the other stuff and land on my exponent. And the way this works is it starts at the base, log base 4. The stuff we pass by is the argument of my log of x plus 8 equals my exponent y plus 3. There we go. Now we're in log form, and I can once again just do an algebra 1 move, minus 3, and I get y equals log base 4 of x plus 8, close them, minus 3. That is my inverse. We'll write it with proper notation on our answer line in green. So there we go. We got log base 4, log base 4 of x, what was it, plus 8 minus 3. Important to note, all the stuff except for this little 4 right here, everything else is in a single line. Okay, that 4 is a subscript. It's lower than everything else. So make sure you guys are writing that appropriately and not having like the 4 be in line with the log and then the x plus 8 look like an exponent. That is wrong, okay? So make sure your 4 is a subscript there. There we go, guys. I think we got everything. Can I erase that without erasing a whole bunch of stuff? Yay, boom, boom. Dude, that's a beast right there. It's a beast of a problem. All right, guys, if you stuck around for this whole thing, I appreciate that, right? Hopefully that helps with graphing stuff, graphing inverses, swapping your x and y's, and even writing a logarithmic equation from an exponential with getting our inverse there. A little loop and swoop. It's pretty dope. You guys are dope, and have a wonderful, fantastic day.